Okay, so hello everyone, my name is Putu Raditya Satriawan with the student number of 231510105, and in this video I will explain to you guys about my answer or my little explanation about the problem that was given to me working grouply with Christiana Dinata with the student number of 75 and also Sachi Devi with the student number of 20. And here from two parts that given to me, I will choose the first part is the number 3, the maximum array, and the second part is to choose I choose the number 2, which is to do the recursive powering. So we'll see the problem, which is to prove this algorithm, to prove the truth of the algorithm is the induction mathematical technique is kindly work on this. So simply it works in that algorithm, which is to finding the maximum elements in an array. I already make the overview of it, which is the problem is in the DNC or divide and conquer, and we will see in our answer base case if n equals to 1, the algorithm returns the element which is correct. If n equals to 1, then return the element of it. And we do the induction now, which is suppose that the algorithm is correctly find we suppose that the algorithm is correct, that it clearly find the maximum for an array size k. The algorithm divides the array into two halves. So with the basic knowledge of basic theory of the DNC of the divide and conquer, it will divide into two halves and finds the maximum in each half recursively and returns the greater value, of course, because this want to find the maximum array. And since the induction hypothesis is correct and it holds both of the half because it's divided by 2, and the final comparison of the two of the half produce the correct result, which is the maximum number of array. Thus the algorithm is correct for all n is greater than 1. And yep, that's simply the induction mathematical of number 3. And we're moving on to the second part, which is I picked the second question to do the recursive powering. And here I already wrote it actually. Yep. And you can see right here the Tn or the recurrence relation here I wrote is Tn, which is O1 in n equals 1, and Tn over 2 plus O1 in n over is greater or equals than 2. So with using the recurrence relation before and using the master theorem, we can know that A equals to 1 for one recursive calls, B equals to 2, which is input is half by 2, and C is additional work. C is 0, which is additional work where that is constant. C is 0, and since log 2 1 equals to 0, I already wrote it. Since log 2 1 equals to 0 and C is 0, we apply the master theorem, which is resulting this time complexity, which is Tn equals to O log n. And this is the mathematical induction. Is the base case is T1 and it holds 0 O1 constantly, and we assume that Tk is O log k. So it basically means it's basically resulting that Tk plus 1 is equals to Tk plus 1 over 2 plus O1, which is resulting our final time complexity is Tn equals to O log n. So yep, that's basically the explanation of the both of the segment, and yep, that's all the explanation, and thank you for watching this video.